We did the FM transmitter project. My name is Krishneel.
I'm Matt Tolman.
And it's just
that's the picture of our chip right there, so you can get it. That's one image of it. Okay, so the requirements.
Alright, so the requirements for this was that basically it just has to output a FM radio signal through the regular band for US from 88 to 108 kilohertz. Megahertz. And we have to be able to change the frequency, just step it up, step it down, and ours does it but in 0.2 megahertz intervals, which was different than what the data sheet told us. The data sheet was terrible. Came from China, I guess a lot of things got messed up in translation. We had to figure a lot of things out ourselves. But it has a reset, and it's supposed to have a UR controlled initialization.
Specifications. We need to implement an embedded computer system on the Nexus board. Computer system should be centered around the microplay software processor, and UR controlled initialization and transmit frequency. It should use button 0 to increment, button 3 to decrement, and then button 2 to reset the LCD to the 100 megahertz, which is the default.
Okay, so we used our Nexus board, our Nexus 1, to control everything basically. We had our audio source is our computer. We connect it to a 3.5mm jack, which is pretty standard. It's what you use for all your MP3 players and stuff. So you could even use it to connect to a microphone if you wanted, to use it as like a wireless microphone if you had a wired microphone. So that's a nice application too. We connected the LCD screen the same way we've been doing through all our other projects in the GPIO. The antenna is just a wire connected to it.
It's a certain length you need for the board for the right distance and everything. This is the software flow chart. It's a basic representation of everything that the software is doing. We start by initializing the chips, the VMR 6512 chip to the frequency we want, and then we check the data to see if it was sent successfully, and then the main piece of our code, we check for the buttons to press and then increment the LCD screen while sending the output signal to make the chip increment. Okay, this is the pin layout for our board, the different settings it does. These are the ones we used. The ground antenna, the up and down increment, and the VCC reset. Then these are the two inputs from the audio jack. We have a little connector that takes the two signals to the board and the ground.
The other ports are for, this isn't used. This one right here is to convert, if we wanted, we had the option of either using analog or digital input, but everything basically outputs in analog for sound, so we use the analog. These are the digital inputs, and this is the clock if we did do digital or we didn't.
Okay, so for the design overview, the first thing we did was acquire the hardware necessary and basically just construct the whole system. Then we started developing the software, and we programmed the buttons to send an active low. When you press the buttons, it sends the signal to the chip and then starts incrementing and decrementing. I don't know if decrementing is the right word. The UART is to initialize the chip to the right frequency that we wanted. And then a lot of what we did was, like towards the end, was just calibrating the LCD screen to match the same incrementing rate as the chip increments, because it's a little inconsistent. But that was basically changing the processing rate of the code.
The main thing with getting our LCD to sync up with the actual chip was getting the timing down for basically the count. Basically, we had to get to the right number so that when we hold it down, that the LCD would increment at the same rate that the FM transmitter was actually changing the frequency. And we had to take into account that, like, you know, if you press it, if you tap it, like, it the data sheet didn't tell us what size of an impulse to give it in order to increment. So we had to figure that out ourselves, and once we found that out, everything pretty much UARTs just linked up.
We could test the frequency by using, well, just checking if it was outputting, and then also we got the oscilloscope to hook up to it so we could measure the frequency more exactly.
The main difficulty we had was that our chip would not read our UART data correctly. We confirmed that we were sending data and that it was sending the right data and it was receiving the data, because when we sent it to the RX of the UART, it would transmit back the exact data that we were trying to send it. So we confirmed that we were sending the right data, but for some reason we could never get it to work correctly. We did a lot of troubleshooting. We spent like a good 15 hours. We got nowhere with that. But yeah, we confirmed that all the specs were correct, but unfortunately we didn't get that right.
Any questions?
What's the range of your FM transmitter, like, as opposed to like just one you buy in a store?
Ours goes up to 50 meters, and a normal one is usually only about 10, which is pretty cool. Because usually they're limited so that if you use it in your car, it only transmits to your own car, not cars surrounding you and stuff.
Yeah.
Ours is pretty cool that we could probably transmit to anyone's around us.
Well, I see it in the demo, but what exactly is the status of the project compared to overall goals right now?
Everything works except for the fact that we can't initialize it to a frequency that we wanted.
So it just starts at 100 every time?
So it always just starts at 100 megahertz.
Okay, that's the only thing.
That's the only thing.
Everything else works fine.
It has to start somewhere.
Yeah.
So that's not necessarily a big efficiency.
Yeah, but we wanted to do that and it didn't work.
Let's go to the...
Okay, so we have our radio set to 99.4, and our transmitter starts off at 100, so we just stepped it down to 99.4 now. So this is it works. I'll show you the range.
That's awesome.
So I can go pretty far.
We tested, you could walk
Go all
almost
the way
out
down
the
hallway,
building.
and it'll work all the way to the door.
That's
It's
awesome.
the range is pretty good.
The chip actually goes a little bit out of the 88 and 108, but doesn't really work too well. So we just have the LCD say out of range if it goes past that.
Yeah.
So it's perfect if you want to start your own radio station
Yeah.
for the building.
Yeah, you selling your
I
design.
mean, you can. The only limitation to this is it gets 3.3 volts. If you wanted to amplify it, just amplify the voltage and stuff, the power, and then you can probably overpower some radio stations or something. I have a friend who has a transmitter that has a half-mile radius. It's pretty cool.
You get a FCC range now.
Yeah, and then you got to deal with them and stuff. Yeah.
Great.
Well, let's give them a hand.